You're right, from September, we go right to the end. And let's be honest, I don't make it that tough in here, all right, at all. You come in here, you take notes one day, you go home, don't have to worry about any math. You come back the next day, do an assignment. The only possible thing you could be doing outside of class is studying, and that's all I ask. And some of you still can't even get that done, and it fires me up because a couple of those quizzes yesterday were just a complete embarrassment. And that's it. I'm just going to plainly say it. All right, it was an embarrassment because you guys don't do squat while you're at home. All right, you don't do anything. So now I'm going to go back to the numbers to making sure you're paying attention at home. So hopefully at home you're by your computer screen taking notes and focusing in it. Ready to roll? You guys are good. Keep it up. All right, keep rolling. Here we go. You should have the ability, not after looking at some of those quizzes though, but should have the ability, if I give you a polar coordinate, to turn it into a rectangular coordinate xy. You guys had two formulas you've used for the quiz. Remember, x equals r cosine theta, remember that? And y equals r sine theta. That's how you found the x and the y. Today, we're going backwards. Okay, and it's a lot tougher to go backwards. Today, here's what I'm going to show you today. Here's your rectangular coordinate. Hey, what would it be in polar form now? And it's a lot tougher than just plugging it into an equation. I can tell you that, a lot tougher. You guys see, you only have 3 examples today. There's a reason why you only have 3, because this is going to get serious. Quick. Before I start showing you how to do this, I do want to make one comment so you're aware. When you turn a rectangular into coordinate or into polar, your R value, I want always positive. It will always be positive. And I know you're not going to like this, but this is the way it is. Your angle, when you write it, has to be in radians. All righty? The R value has to be positive, and the theta has to be in radians, not degrees. All right, are we ready to turn our first rectangular coordinate into polar? -2, 0. What I'd like you to do every time, draw a quick ghetto graph, a quick sketch of a graph for me. X, Y axes. Plot -2, 0 on there for me. Plot -2, 0. I'll give you guys a lot of time here. So plot the coordinate on a sketch, X, Y axes. Hopefully you guys know where -2, 0 is, I hope. I can't help you with that part. All right, -2, 0. Hopefully you guys graphed it right here on the x-axis somewhere here. You know, right below -2. And I'm asking for the polar. What would that be on the polar grid now? What would that be on the polar grid? Think about it for a second, because I don't have any fancy formulas for this one. I think we can handle just seeing that point where it would be on the polar grid.
Would it just be 2?
Okay, Isaiah said in class, what would my R value be? Isaiah, how far would it go out?
2.
2.
Because it's opposite.
It's 2. And again, my R value is always positive. I never want a negative. So it's 2. Now can you figure out, and here's what I'm going to call on somebody. First one today. What angle am I at? Think about it. Don't yell anything out. Think about it. Where am I at right now on the angles? AKA, what is that angle? In radians right here. Okay, where am I right now? What is that angle? I know 2 is my R value because it's going to go 2 units out. But what's that angle now in radians? Where's my sheet? There it is. All right, let's do it. Welcome back to the numbers. Already all set. Perfect. 13. This is going to be a rough one today. Not here. Good. Probably skipping maybe. 14. Here we go. Kian, what's that angle on that where I have -2 right now?
180.
180. What? But again, I can't put 180 in because any angle has to be in radians. So do you remember what 180 is?
It's just 1 pi, right?
1 pi, and that's it. 2 comma pi. We're done, guys. That's the polar coordinate. All right. If it's on one of the axes, it's pretty easy. I don't have to do anything fancy. Questions? 2 pi? 2 comma pi is my polar coordinate. Going? All right, now in this next one, we're going to have to do a little work now. -1 radical 3. So everyone go ahead, graph your XY axes for me. Can anybody tell me what quadrant this is going to be in? -1 on the X, positive radical 3 on the Y. What quadrant am I going to be in?
2.
Quadrant 2. Good. So just put a point in. It doesn't have to be precise, everyone. Just put a point in quadrant 2 for me. First thing I'm going to show you, how do I get the R value now? How do I get my R value? And the way we're going to do it is we're going to draw a line segment from the origin to my point. All right. That distance is going to be my R value. All right. That distance from the origin to the point is going to be my R value. How am I going to find it? I'm going to make a right triangle out of it. Draw a vertical line down now from your point. Everyone, draw a vertical line down. I'm going to make a right triangle. You should know the other two sides now. Look at the point we graphed. What was your X? Here we go. What was your X coordinate of the point we graphed? Here we go, 11. Liz, what was the X coordinate of the point we graphed?
Was it 3?
The X coordinate. We just graphed -1 radical, -1. So everyone, hey, -1 is on the X axis. And then Liz, what was the Y coordinate?
3.
3? Are you on question 2?
Radical 3.
Radical 3. So again, -1 on the X, radical 3 on the Y. Everyone see where I got those values? So those are your two sides. You guys tell me now, how can I find R? Pythag. Yep, that's how you're going to find your R values, by using Pythagorean theorem. So we're going to say radical 3 squared plus -1 squared equals R squared. We're going to use the Pythagorean theorem to find the value of R. This drives me nuts too. Anytime you square a negative number, what type of number do you get? Positive. I don't care what your calculator says. You should get 2 positive numbers out of this. All right. Hopefully you're going to your calcs if you have to. Let's find out here. 6. Mason. Here you go, Mason. Radical 3 all squared.
Is it just 3?
Just 3. How about -1 all squared?
1.
1. There you go. R squared equals 4. What are you going to do on both sides to find the R value, Mason? I got.
Are we gonna
Go ahead.
do like a radical 4?
You got it. Take the square root of both sides. So what's my R value in this problem, Mason?
2.
2. Good job. All right. R value is 2. I always find R by doing Pythag. All right. So we got half of the polar point is done. Half. I know the polar point's going to be 2, comma. All right. Now I got to teach you how to find the angle. What quadrant am I in? 2, right? So I am asking for this angle measurement right there. What is the angle in quadrant 2 that I'm at? All right, all right. Here's how I'm going to help you find it. We're going to go to good old SOHCAHTOA. Oh, yikes, right? Sine, cosine, tangent, but I'm going to make it easy for you. You're always going to use tangent. And here's why. We're going to find this angle right here now. Radical 3 is opposite, and the -1 is adjacent. So if you remember with O and A, TOA, you use tangent. And those are the sides you're going to have every time. Every problem, you're going to have those sides, opposite and adjacent. So we're always going to use tangent to find our angle. Tangent of theta, that's the angle I'm looking for, equals, everyone ready? TOA. Opposite, what was our opposite? Stop asking people and just calling somebody. Here we go. Nope. There we go. Hi, Anna. What's our opposite side? Radical 3 over our adjacent side, which is -1. Good. So that's why we always use tangent, because we will always have the opposite and adjacent. All right, how do I get the angle? Now you go calculator, everybody. Go calculator. Make sure it's in degree mode right now. Well, you said my answer had to be in radians. We'll get to that. Make sure it's in degree mode right now. Calc's in degree mode. To find the angle, you don't use your tangent button, you use the -1 button above it. So we're going to find the angle by doing tan of -1, radical 3 over -1. That's how we're going to find our angle. So we're going to do second tangent. I'll do it with you. Second tangent, radical 3. If anybody doesn't know how to get these buttons, talk to me now. Over -1. Now you're going to see something real quick. Hey, Carlino, that angle's not in quadrant 2, is it? That's not in quadrant 2, is it, guys? Okay, your calculator is only programmed to give you reference angles back. Your calculator is only programmed to give you reference angles back. So what your calculator just told you was, it won't give you the angle in quadrant 2. It's just going to tell you that this reference angle is 60 degrees. That's all it's going to do for you. That reference angle right there is 60 degrees. That's all it's going to give you. Now it's on you to get the angle in quadrant 2. This is why we did all that work on Thursday and Friday, where I gave you the reference angle and the quadrant, and then you gave me the angle back. So I got it. Reference angle is 60. It's got to be in quadrant 2. Think about how you're going to find the angle for me. With all that I've just given you, 60-degree reference angle, but it's got to be in quadrant 2. How are you going to get to the angle I need? And remember, when you tell me this angle, that angle better be located in quadrant 2. So between 90 and 180, this angle you give me. So that angle was 60. So in quad 2, what would it be in quad 2? All right, ready to help me out? Let's see. There we go. Hi, Ella.
Hi.
How do you get that angle in quad 2 if you already know it's 60?
I did 180 minus 60.
I like it. 180 minus 60. So what's the angle in quad 2?
120.
Good job. So my angle theta is 120 I'm looking for. I can't put that in the answer though. I can't say 2 comma 120. You guys remember what I said at the beginning? What's that angle always has to be in? Polar coordinates, it always has to be in radians. So we do have to convert it. All right, you cannot, again, this would be an unacceptable answer, 2 comma 120. That's in degrees. Any polar coordinate from now on in radians. I got you. There you go.
I could see.
Anybody remember what we have to do? Multiply by, if I need it in radians, pi over 180. If you need it in radians, which you will every time. So this is going to be your final step here. Leave the pi in your answer, and then reduce 120 over 180. So just go back to your calcs, little fraction template, 120 over 180, 2/3, so 2 pi over 3. There you go, R value positive, angle in radians. So there's your polar point for -1 radical 3, 2 pi over 3. The only thing I'm going to change is the quadrant we're in. That's it. That's the only thing I'm going to change on you is the quadrant we're in. Last one. Three -1. Change 3 -1 into polar. Graph it. Know what quadrant you're in. Graph it. Draw a line from the origin to that point. That's your R value. So 3 -1. Draw your line from the origin to here. There's your R value. Always draw. Hey, I know when you're making a right triangle, always do your vertical line up. All right, always do a vertical line up or down. There you go. Okay, let me start hitting you guys up for answers. What's my X and my Y coordinate so I can fill out this triangle? 11. Liz, going back to you. What's my x coordinate here?
3.
3. So on the x-axis is 3. How about the y coordinate?
-1.
There you go, -1. Pythag, 3 squared plus, this should turn out to be a positive number, -1 squared equals r squared. That's how you're going to find your r value for the polar coordinate. All right, going back to you guys for answers. 12. Dan, here we go. 3 squared.
3 squared is 9.
9. -1 squared.
-1 squared, that's just 1.
1 equals r squared. So I get 10 equals r squared. How do I solve for r?
You square root both of them.
Square root both sides. I don't want decimals, everybody. I don't want decimals. There's no need for them. Just keep it as a radical, please. Just keep it as a radical. In this case, radical 10. Avoid the decimals. Radical 10. There's your r value. That's probably the easiest one to find, right? Next, the angle in the fourth quadrant. So I'm going to go tangent. Always use tangent because you always have opposite and adjacent. And remember, you're finding the reference angle when you're doing this. You're finding the reference angle. All right, going back to you guys. I need from somebody what's the opposite and adjacent side lengths. The opposite and adjacent side lengths. Liz, you're good today. You proved to me you're good deal. Bassett, what's the opposite side here of that angle I'm looking for?
-1.
And what about adjacent?
3.
3, good job. Second button, second inverse to find the reference angle. So tan to the -1. And I know you guys are going to get decimals here. Round to the nearest whole number if that happens, all right? Just round to the nearest whole number, make things easier. So second tangent, -1/3, or 1 over. So about 18 degrees. I know it's got a negative, but we're just going in the opposite direction. About 18 degrees for your reference angle. Okay, 18 degrees. Again, that's not the angle I want. I want an angle in the fourth quadrant. Somebody find me, knowing the reference angle's 18. I'll give you a couple minutes. Knowing the reference angle's 18, what's the angle in the fourth quadrant? A lot involved here, a lot. The second part of the unit's pretty tough. Second part's pretty tough. All right, I've given you some time to think about it. How do you find the angle in quadrant 4 if you know the reference angle's 18? Colin, help me out here. How do you find that angle in quadrant 4?
I just did 360 minus 18.
Good, what'd you get?
342.
Good, 342 degrees. I don't put degrees in my polar coordinates, I put radians. So last thing you need to do, change 342 to radians. Multiply it by pi over 180. And all I'm going to ask you to do, please reduce 342 over 180 for me. I'll give you time to do that. All right, what did you end up getting when you reduce 342 over 180? What's my answer in radians now? What is on fire here today with you? Hunter, what do you end up with?
You get 19 pi over 10.
Good job. Okay, so that's what my polar coordinate ended up being. Radical 10, 19 pi over 10. All right. Before I end the session, period 2 thought this was pretty helpful, so I'll do it with you guys too, is if I'm in a certain quadrant and I know the reference angle, how do I find the angle? Because some of you guys might be struggling with, do I do 360, 180, plus, minus? So if you want, here you go. Here are the rules. If you're in quadrant 2, you always do 180 minus the reference angle to find it. All right, 180 minus the reference angle. That's what we did in the problem before. Third quadrant is where kids have the most trouble with. It's 180 plus your reference angle if you're in quadrant 3. All right, if you're in quad 3. And then finally, we just did this in quad 4. You do 360 minus the reference angle. And just a bonus question before we leave. Why didn't I put anything in quad 1? Why didn't I put a rule in quadrant 1? Whatever it is, like if it's 58 and you're in quad 1, it's 58. That's your angle. Whatever your reference angle is, that is your angle in quad 1. All right, I'm good. All right, I'm just going to start coming down a little bit harder on some of you here as far as expectation-wise, because if you wanted to give up in the fourth quarter, you should have dropped it earlier in the year. All right, have a good night, everyone. Take care. Be safe. Be smart.